All right, example 2 of proving triangles similar. Um, are these two triangles similar, EFG and IJK? And if they are, we'd like to know exactly what kind of angle matchup can we make. Here's something where we have SSS information. We have all the sides of both triangles, and we'd like to see if they are similar. Well, what we need to do, because what we're given is length information instead of angle information like in the last example, we need to calculate some ratios and see if things are proportional. And if so, we can conclude similarity, and then we get the angle congruences that you get from similarity. So, let me zoom in a little bit. Okay. So let's calculate, let's do the scale factor idea. So we actually have to kind of look at it and sort of see. We don't know exactly how they're corresponding. It should be pretty easy because I made the numbers pretty nice. But we need to look at, say, let's look at IK. We don't know right off the bat what that should be matching to. But what we can do is we can notice that that's the longest of these three sides. Well, if that's going to match up, that should correspond to the longest of these three, right? So it wouldn't make sense to match, to take the ratio of IK, the longest in the big triangle, with either EF or FG, because those clearly aren't going to be the matching parts. So that's one thing you can do is look at like biggest, smallest, things like that. So IK over EG, well, I made that really easy. In general, it's going to be a little more complicated. That's 2. And then let's look at the other ones. Okay, let's see. How about the smallest with the smallest? JK over FG. Okay, that's 4 over 2 is 2. Okay, so far so good, but we'd really like to match them all up. We need that for the SSS congruence. We can't say just because 2 pairs of sides match, that's not enough. And so IJ, that's the middle side, the middle size side, over EF. And yep, it's looking good. Hopefully that was kind of, you could look at it, sort of glance at it and see that that's pretty likely. So all ratios equal. So all sides are proportional. So SSS similarity says that the triangles are similar. And well, we need to make that precise. So triangle, oops, that didn't work. Triangle, let's say EFG is similar to triangle. Okay, so E was opposite the shortest side. That's going to correspond to I. F was opposite the longest side. That's going to correspond to J. And G, the last one I named here. So I just named these in whatever order I felt like, but then it's got to match over here. And then G is opposite the middle side. And so K, that's the mama bear, I guess, in the Goldilocks situation. That's going to be IJK. Okay. So it would not be correct if I didn't have these in exactly this order that matches this order, just like you've been told for like congruence terms. Okay. And in particular, angle, what did I ask about? Angle, sorry, GEF. Okay, angle GEF, let's just make sure we use this. That's something where you don't even have to look at the picture. If you've got this precise, you just change each letter to the corresponding letter. So G is the last letter here. E is the first one, that corresponds to I. Ooh, I need angle marker. And then F, that's the middle one, that's J. All right, so angle KIJ. And indeed, that's that sort of smallish angle here, KIJ, that corresponds to GEF here, which looks like the smallest of those three angles. Okay, so that's another one. So that's kind of the opposite field from the previous one. There we had angle information because of like vertical angles and parallels, and then we concluded some proportionality stuff. about the sides. Here we are given all the side information. We test to make sure that those are all really proportional, and you have to check all of this. But then when you get that, then you get the angle stuff for free, and you just have to be careful about exactly how you're matching them up. Let's do one more example. Okay. Are these triangles similar? We've got a left and right triangle here. Are the two triangles similar? Well, it looks like we might have enough, exactly that kind of information. I've marked that these guys are known to be congruent, right? So we have I just can't type angle, sorry. Angle MOP is advertised to be congruent to NOQ. Okay, so far so good. If we had one more pair of congruent angles, we'd be good. And it looks like, oh, maybe like OPM is 90 and ONQ is 90. Well, I tried to make it so that they at a glance they look like 90, but if you really look at it, I don't think so. Let's zoom in a little bit here. Those are not looking like 90. But wait a minute, maybe MP is parallel to NQ. Well, it's not given, but what if that's true? I actually did try to make it so that they're pretty close to parallel, but in fact that's not. That even wouldn't help us, because if MP is slanting up and to the right, then OMP is an acute angle, slightly less than 90. And if NQ is slanting up and to the right the same amount, well, that makes ONQ an obtuse angle. Wait a minute. Oh, those don't match, right? So this is really not going to work, okay? So even if MP and NQ were parallel, and I didn't tell you that, so you shouldn't assume it, but even if they were, these would not be similar, since angle OMP is not congruent to angle NOQ. Okay, and as soon as you have the angles not being congruent, then you're toast. And so even if things kind of just at a glance may look like it works out, you have to be really careful. We were just given one angle pair, and that's not enough to conclude similarity.